Verizon, like if you don't use up all your, keeping the lights, keeping the grid stable, they're not really involved they're not telling Utah how many coal-fired plants they can build or which ones to decommission. Okay, the state's PUC decides that along with the utility, but they do have an impact. Sure. And this is the last piece. Here's the installation rate of the first battleground of the solar wars, and you can see the reason. It's, you know, that this is the area here, right? I mean, like my house is right here in Utah. Okay, I did it. I'm paying the way I did it myself, but I hired an electrician. But I'm paying 5 cents a kilowatt hour. I'm taking block 3 billing. I'm being charged 17 cents a kilowatt hour, and it costs me 5 cents, and I'm levelized for the next 20 years. Only because if that same array in Boulder, you'd be paying 7 or 8 cents a kilowatt hour probably at that time because you don't have as much sun. And this is kind of the combination of all these effects has made the first battle kicking off with net metering. Does anyone not know what net metering is? It seems like this audience is extremely good. Okay, so the way net metering works is very simple. It's like rollover minutes for Verizon. Like if you don't use up all your phone minutes, you get to roll them over the next day or the next month. Like on my house, I have it, all the data acquired from my solar panels. Typically during the summer, when your solar array on top of your house is producing a lot of electricity, it produces more electricity than the loads in your house can consume. Okay? So the electricity, the physics of electricity, it goes to the vacuum. It's going to go somewhere. So it'll go back out to the grid. It'll go through the utilities meter. They own that meter. Okay? It'll go back to their grid. And full net metering, the concept is they'll give you full retail credits, and you can roll them over next day, next month. Some states, they have a yearly kind of rollover, like in Utah, after a year. If you have too much built up, they just take it for free. I think in Colorado, they give you some money.
2 cents.
2 cents, yeah, but not much. But that's fine. I think people should properly size their arrays. I'm not a firm believer, and we'll go wide. Net metering is no longer going to be an issue within 2 or 3 years. Okay?
Our rec is now 0.5. They changed it about 30 days ago.
Yeah.
From 2 cents to a half.
Yep. So that's what, and this is the first battle. So Rocky Mountain Power started talking about doing something about 3 years ago. California, the utilities in California, SCE, PG&E, they started going to the commission saying we can no longer give you full retail credits. They only want to give wholesale. They're saying we don't want to buy your electricity, and it's not good quality electricity really. It's just, you know, your electricity. We can buy electricity for 4 cents. Why should we give you a 15-cent credit? And they have a point there. And this is where I think we're going to have a balance. And I've done a lot of consulting with municipal utilities on how to do net metering. Some municipalities come to me and say, Bill, we're having so much load defection, we're stopping it. We're just not allowing solar installations. They're basically saying you cannot install solar on your own roof because without curtailment control, without being able to control the electricity, you need their permission to install solar on your roof, unless you could stop it somehow. So what I told the manager of this utility is, no, don't just kill it. What's a fair price? What would you accept? And he's like, well, I could pay 4 or 5 cents. Well, then offer that. And a lot of his people still went with solar. The economics were so good, even though they were only getting 4 or 5 cents as their rollover minute, so to speak, it didn't kill solar. It was a fair compromise. And I think that's the battle that's going on. The concept is called, what is the value of solar? Some studies have said it's 30 cents a kilowatt hour. Lincoln Electric, who was one of my clients in Nebraska, they came out with a robust study saying it's 4 cents a kilowatt hour, not 30. What's the difference? Anyone know? Some studies have the environmental cost involved, pollution, the cost of pollution. Some just basically have the avoided fuel cost plus some avoided operations and maintenance. So the value of solar for net metering, but I think this battle is going to go away, and we'll see how. Okay, here's 2012. This is when the battle began, mainly because you can see you can see the generation from solar panels just started going ballistic. Before that, utilities were fine with full retail credits for net metering because so few customers were going solar. It was just noise. It was a pittance. But now let's see what's happening. I did a study for a small municipality, okay, 6,000 meters, and basically the average customer bill is about $100. And here you'll see over time, 2013, 14, 15, you can see these are the number of customers that were installing solar. They were starting to see exponential load defection. Customers weren't leaving the grid, they were just using less electricity. And here's the interesting part of the study. The customers that were leaving the grid, this is their average bill, $300-400. So the utility is losing their highest margin customers. It's killing them. This is kind of the beginning of the death spiral. These utilities now will have to raise their rates on everybody else that hasn't gone solar, incentivizing them to go solar. So, and the cost of solar keeps going down. The cost for them to maintain and buy coal and natural gas keeps going up. It is a major, major issue with a lot of utilities that are in areas of the country where solar is very good. Okay, so we'll go on, and you can see this is kind of the percentage of revenue they're losing. And here's the most important thing. With the budgets increasing, their revenue decreasing, now they're projected they're going to have deficits. So they're going to have to go back to their town council and say, we need to raise rates. Okay. Now this is what started, and this is what Rocky Mountain Power, Pacific Core, and Southern California Edison, they're doing, and I've helped some of these large utilities kind of do software analytics on their data to show them, we can do predictive analytics, and I can predict your next customers to defect. We know that there are like 12 features of a person that goes solar, and the solar installation companies know who to target. Obviously customers with a high bill, a home that's not too old, flatter roofs, high incomes, they know exactly what kind of customers to target. And it's not, you can predict which customers will defect. And they want to know that because they need to plan, utilities need to plan 10, 20 years out. When you want to build a new combined cycle natural gas plant, okay, this is a big decision. You need to amortize that thing over 30, 40 years. Okay, so they're having a hard time with CapEx decisions with this load defection. That's kind of one of the reasons for the battle. So the current state of net metering, we have the 3 states that first battled, Nevada, Arizona, California. The PUC in Nevada allowed them to reduce the credit by 75%. California kind of kept the same, except California now is going to charge time of use billing to customers that install solar. They have what's called, does anyone know what the duck curve is? The duck curve. You must know.
Explain it, please.
Okay, so in California especially, they saw so many installations being put on the grid that typically during the day, solar is a perfect peaking feedstock. It peaks when loads peak. In the summer when it's hot, ACs are on. That's when you want solar. So solar is actually, their loads used to get high around 10, 11 and peak. They keep peaking through 1, 2 p.m., 3 p.m. Now they're not peaking through noon anymore. They're going down. But guess what happens when everyone comes home at 6? So they gain this weird curve. And it's an issue to deal with. Now, my complaint to them is, okay, you can flatten this duck curve out with one simple change. Just put in time of use pricing, especially to commercial customers. When residents are coming home, commercial entities should be shutting down their electric use. If you have time of use, if you have between 4 p.m. and 9 p.m., if you have really high rates for your C&I customers, that curve is gone. They will adapt. They will not use any electricity to avoid that high charge, and therefore it will be a much flatter curve. But these are issues that Germany faced this issue, Hawaii's faced, any area that's seen a lot of solar installations. California's still not there yet. Colorado isn't. I mean, nationwide, does anyone know what penetration we're at? Is it 1% or 2%? I mean, I always say, people that dislike solar, that's what they go to me, well, if solar's so great, how come it's still 1%? Well, it took coal 80 years to get up to 30%. It'll take a few years for solar to get to 10 and 15, but it'll get there. Okay, the key thing to think about is free market competition innovation is starting to happen at a fantastic rate. And utilities, whether they're munis or IOUs, they do have the same problem. They have to manage the grid. They're very conservative. You don't get, when I work for a utility, you don't get paid to innovate. You get paid to deliver profits and keep the grid stable. Keep your customers happy. I mean, innovation means lower cost to consumers typically, which is not good if you're an investor in utility. But now we're seeing just amazing amounts of innovation, especially around smart inverter technology. And what most of the inverter companies tell me is, this is why net metering battle is going to go away. they're starting to design their inverters with some DC storage. So when your solar panel is cranking way more energy than you need, okay, you'll have some DC storage with the inverter, okay? It'll store that extra energy. Then, if you're still producing too much, you'll have curtailment control device, which basically, it's like, it'll be, and that's how the Western grid is separated from the Eastern grid. There's a large transformer that transforms AC to DC. When you transform, it creates a barrier. So if you can make sure that your electricity never hits the utilities meter, maybe you don't even have to notify them when you put solar in your house. Why should you? Do you have to notify a utility when you put a new HVAC system in your house? No. Why should you? Okay? That's why the inverter companies, and this is Tesla, SolarEdge, Enphase, all the innovative inverter companies, they're going to figure a way out to eliminate net metering. Okay, the excess energy you create, you're not going to net it back. You'll just save it to be used at night.
So I was recently told by a solar provider that they cannot install a standalone system because of their agreement with Xcel Energy.
Every state's different. Commercial entities have hit this problem for years. They're called interconnection agreements. I think CU had this problem. They wanted to build a microgrid, or they have built one, but they can't turn it on. So you have to prove to the commission utility that no electricity under any circumstance will ever go to the grid. Because if it goes back to the grid could be down, linemen could be working on the grid, they can get injured. The utility companies needs to protect the grid to make the economy work. If the grid goes down, if we don't fund the utilities, that's bad too, that everyone loses. So even though this is a battle, and I totally don't like the idea of not letting customers do stuff inside their premise, as long as it doesn't affect the utility company, they shouldn't have a say. But in some states, they can. They could actually label you as they have a franchise monopoly. They label you as an energy producer, and you're competing with them, even though you're only selling it to yourself. And it's, these monopolies are government enforced. I mean, they can probably put you in jail if you actually try to do it.
Assuming you have the knowledge, is it possible to have your house divided into two panels, one of which runs only off your solar?
Every municipality, state, cities are involved here too. Cities have building codes, and they work with the utility companies. These battles are just starting to percolate. The net metering battle was the first. The second one is the tariff battle. Now a tariff is basically, every state has a different tariff. They're basically separate customers between residential, commercial, and industrial. And for years, utilities have issues with industrial customers creating their own electricity because they're so big, they think, well, and they have electricians on staff, and steel plants and cement plants typically have had their own coal burning plant or a 40 megawatt natural gas plant, so that industrial customers negotiate their rates directly with the utility. They have to give them cheap rates, or they'll create their own electricity. Commercial and residential customers, it's just typically hasn't been an option to have your own power plant, your own microgrid. It's starting to get more popular, but basically this is the way that the tariff works, and this battle is interesting. Who knows what a demand charge is?
Last company I worked for, the demand charges were higher than kilowatt hour charges because their air conditioner peaked once a day.
Yeah. So electric utilities sell two products. They kilowatt hours and kilowatt. They sell usage and power. Commercial customers pay for the highest 15-minute interval of power. It's not an average, it's an interval. So the meters basically have a high watermark register, and the first 15 minutes comes in, they say, okay, you used 140 kilowatts. The next 15 was 160. They keep track for a monthly billing period. Your highest 15-minute charge is your demand charge. And every utility charge is a little bit different for each state. So this is kind of visually, if you don't know what demand is versus consumption, both customers use 5 gallons. They consume 5 gallons of water. But one went 5 gallons a minute. So this one that went 5 gallons a minute, they'll pay 3 times more for their bill than the one that used, even though they're consuming the same amount of electricity or water, the one that's consuming it at a higher rate will have a much higher bill. And here's how it's evolved over time. So on the left here we have what utilities had. I won't give them the name. I don't want to get them ticked off at me. They just 25% of a bill was the demand charge. That was like 10 years ago. Now, 50%. They've learned that if they pack as much as they can into the power charge, that 15-minute average cannot be touched by energy efficiency, demand-side management, or solar. You need something else. Those three things will not change the demand charge. Actually, solar will, and I've submitted some grocery stores, and we've done studies in the hot desert where if you just put solar panels on top of your plate, top of the plate, it reduces cooling demand by 30%. So if you reduce all demand by 30%, you'll also reduce your demand charge. But solar will alone, you have one cloudy day, and your store hits the demand charge, that's it for the month. Or if you make a mistake, some towns, they test a new water pump out without closing the other one down, they get put on a new rate schedule, and they can't get off it for another year. So the utilities now want to move demand charges to residential customers. That will basically eliminate the economic value of solar. No one will install solar if you have to pay a demand charge. There's only one way. What's the one way you could avoid the demand charge?
Batteries.
Exactly. That's why I say innovation, and here's a schedule in Colorado. This is what a tariff looks like. So utilities, they're doing analytics. And the company they used to do consulting for, we help them with that. Big data analytics on, if we morph our tariff this way and that way, if we eliminate the top tier billing, which is great for solar, how much less solar? They're trying to push back the solar surge so they can figure out how to deal with this innovation and change. It's hard. But I'm going to go over this. It's basically complex. The final battleground, grid defection. And this is where I got, about a year ago, I was brought down to Las Vegas. I had written some articles about the battle in Las Vegas. The Economist from the UK brought me down and we filmed a documentary on the solar wars of grid defection. What happened was, we went back earlier, remember those power purchase agreements that NV Energy was buying? The casinos, which are like, one casino is 5% of their load. Well, I mean, that's 5%. I mean, they were paying, some commercial customers I talked to, they're paying over $100 million a year in electricity. I don't know what MGM was paying, but they're like, I don't want to pay 15 cents. I'm going to buy that array in southern Utah. They're only charging 3. And that was the battle. And actually, they won that battle in a way. They had to pay $89 million exit fee in order to buy their own power. And some states have exit fees, some don't. The reason for an exit fee is the concept of stranded cost. If you're a really big data center and you build in a new territory, that utility is going to have to build you a substation. They may have to build out a whole new power plant just for you. And then 5 years later, if you leave, what are they going to do with it? It's a big paperweight.
That's happening in the bacon field.
Right now, it's going to be tough to sell communities on the stranded asset cost for residential customers. It's like, no, I'm sorry. You did not build a coal plant for my house. You did not. Anyway, so just go some of the interviews I had with The Guardian, and that's why I started talking about the death spiral for utilities. If you start losing your large commercial customers to maybe microgrids, storage, or directly buying power from First Solar or Google or Apple, this is happening. Companies want to be sustainable, okay? And they also want cheaper rates. Why not do both? So we saw this earlier. The reason I have it here is this is kind of the reason these MGM, they have a sustainability team, and they have a CFO who wants to pay less. They saw these trends. Once it got down below 4 cents a kilowatt hour for power purchase, they said, I don't care how much of an exit fee we have to pay, the economics still work. They paid $89 million, and the payback period is still going to be less than 6 years. Yeah, so 87 million is what they paid. Wind paid 17. Now Switch started this. There's a large data center. They wanted to buy their own power. The commission wouldn't let them, and they worked out a deal with NV Energy. Now Switch is suing them because they said they were, I don't know, this won't work. If you're Switch, you couldn't be deceived. You have to have people on staff that know what they're doing. But anyway, so they want to now buy their own power. Now, sustainability is a big factor in corporations, and that's going to really affect this grid defection. Residential customers, we're not going to defect for a while. It's pretty hard. I've looked into it because I wanted to do a test on my own home, just like I put solar. What would it take? Obviously, I would need, and I've actually designed a microgrid for a small town called Fry Canyon. And when you want to be your own grid, it can get real expensive. You need to have battery storage, charge controllers. You need a full-time generator, something that generates, and then you need a backup gen set too, if you want to be truly Rambo. If you want to be Rambo or off-grid, it can be really costly. But you can get close, but getting 100%, I mean, that's the whole renewable concept. You can get to an 80% renewable economy, fairly inexpensively, but going that last 20% gets really hard financially.